Elite AI researchers are observing a sudden workflow inversion. They have moved from spending 80% of their time manually typing code in an integrated development environment, or IDE, to nearly zero. An IDE is a software application that provides comprehensive facilities to computer programmers for software development. Andrei Karpathy describes this state as AI psychosis. You stop typing syntax and spend your day orchestrating macro actions across swarms of agents. You are manifesting your will rather than performing the labor. Developer productivity is no longer measured by lines of code written per hour. The human as typist model has been rendered obsolete by autonomous systems. The new definitive metric is token throughput. This represents the total volume of parallel agent streams a single human can manage at once. AI has transitioned to a Loopy architecture. Interactions no longer conclude with a single prompt and response. Instead, agents maintain persistent execution loops until a specific task is verified as complete. Surviving this shift requires a total refactoring of product design. We are looking at the end of bespoke software interfaces and the requirement for a new macroeconomic infrastructure. Human engineers are evolving from creators of code into conductors of non-human intent. This is the Loopy stack architecture. A base large language model wrapped in an agent harness creates a claw, a persistent, autonomous agent. Claws deploy in parallel swarms using closed-loop optimization. This enables auto-research. Agents iteratively edit code and evaluate results until metrics are met. We are seeing the meta-optimization of research organizations. Institutions are being formalized as editable markdown files, known as program.md, which agents iteratively improve. This quadrant chart maps model jaggedness. They reach PhD levels in verifiable domains, like code, but fail in non-verifiable domains, like prose. Because they are trained via reinforcement learning, these models require strict, objective evaluation metrics to achieve superhuman optimization. This explains why a model can optimize complex kernel hyperparameters while simultaneously failing to stop telling the same 5-year-old joke about atoms. It is God-tier at what it can verify and stagnant at what it cannot. In this environment, model failure is rarely a capability limitation. It is a human skill issue, a failure to orchestrate the agent or define proper evaluation metrics. The orchestration of agents is refactoring consumer product design. The logic used in back-end research is migrating to how we interact with real-world hardware. The definitive case study for this is Karpathy's home agent, Dobby. Dobby used network IP scanning to autonomously reverse engineer the local device APIs for smart lights, HVAC systems, and security cameras. An API is a set of rules that allows different software programs to communicate. The agent acts as a universal translator, connecting natural language directly to these raw API endpoints. Graphical user interfaces, or GUIs, were only created because humans cannot naturally read APIs. They are artifacts of human limitation. As the Model Context Protocol, or MCP, matures, bespoke consumer app UIs become software over production. MCP is an open standard that enables developers to provide error-free integrations between their data and AI models. The primary consumer of future software is the autonomous agent, not the human. This makes the traditional App Store and the subscription-based SaaS model functionally obsolete. There is a common assumption that driving the cost of software production towards zero will destroy engineering employment. The Jevons paradox of software suggests the opposite. Radically cheaper production historically unlocks infinite latent demand for bespoke, ephemeral code that was once too expensive to build. The challenge is macroeconomic. We must manage and tax the millions of autonomous non-human workers generating this output. Agents require cryptographic identities, specifically decentralized identifier or DID bindings. These allow agents to authenticate and spend compute tokens. All Internet namespaces originate within institutional bodies like ICANN and the International Telecommunication Union, which manage the assignment of top-level domains. The ITU assigned the .ai top-level domain to the island of Anguilla, creating a functional minimum viable product for algorithmic public funding. Registration fees from global AI companies are funneled directly into a sovereign digital endowment for the island's citizens. Revenue from the .ai domain rose from 4% of the government budget in 2018 to 25% by 2025, funding physical public infrastructure. This autonomous revenue now accounts for 16% of Anguilla's entire gross domestic product. We can scale this model globally through decentralized agent identity protocols to intentionally route digital rent. Anguilla demonstrates that namespace fees can replace traditional tax bases. Taxing autonomous compute and digital real estate provides a functional blueprint for subsidizing a high universal basic income. This shift requires a final change: the total rewriting of technical education and software documentation. Human-to-human video tutorials are becoming obsolete. Documentation is now written for machine ingestion, like this 200-line Python script for MicroGPT, designed for an agent to read and then teach to a human. Experts will pivot to writing structured skills, instructional frameworks that guide infinitely patient agents as they tutor human users. We are transitioning from the role of syntax bricklayers to the role of architects of automated, recursive systems. Maximizing token throughput without building the underlying economic and identity namespace is a systemic risk. Infrastructure is destiny. The capital to fund the future exists, but the plumbing is not yet in place. We are now tasked with building the financial and identity infrastructure to route these agentic transactions before systems scale beyond our ability to regulate them.